Hi YouTubers, welcome back. This is the 5th installment in our video series dedicated to teaching you how to build a chess engine from scratch in the Java programming language. Recall that in the last video the focus was on the knight class and particularly how to implement the calculate legal moves method. And I did not finish the implementation because I felt like the video was getting a little bit too long. I'm going to try to keep these videos within a 20-minute time frame if I can. I'm going to spend the rest of this video talking about what we need to do in order to complete that implementation, and we'll make some minor enhancements to the method as well based on some observations that we can make. So the first thing we want to do here is let's sort of recap how this algorithm works. We want to loop through these candidate offsets, right? And we want to go ahead and apply the offset to the current position, and if the that position is valid, if it's a valid tile, if it corresponds with a valid tile on our board, we then want to check to see if that tile is occupied or not. If it's not occupied, we're just going to add a new non-attacking move. And if it is occupied, we're going and it's occupied by an enemy piece, we want to add a new attacking move. And recall that I said that the move class is stubbed out, so there's no implementation here, but we will go ahead and do that if time permits in this video. But what I did want to focus on in this video series is the exceptions to this rule. So first, let's go ahead and uncomment out this method. Right. So is valid tile coordinate, and we're going to give it candidate destination coordinate. We're going to create this method. And really all we need to do here is to check to see if the coordinate, we want to say return coordinate is greater than or equal to 0 and coordinate is less than 64. So this is really going to tell us whether or not we are, after applying the offset, if the tile number that we're looking at is in bounds or out of bounds of the chessboard, right? So that's this method. And you know, when you look at this method, you're going, I'm thinking that it's going to be applicable not just to the knight, but to a lot of different piece types when looking at how they work and how their legal moves are applied. So I'm going to see if I can take this method and apply a refactoring, and I want to move it. Yeah, this is just saying that we're not using, wait, there are no variables that have reference type. Would you like to make is valid static and then move? Ah, yes. So what this is just saying is this is a member field. It's not a static method. So let's make that static and move it. Replace instance qualifiers with class reference, refactor. So now, okay, so now we've just made this method static. Let's refactor and move it. We want to move this to a class called BoardUtils, and let's do that refactor. Not exist, you want to create it? Yes. So what we've basically done is we've taken this method, it's a static method, and we've moved it to BoardUtils, and we've made it public. Remember that right before we did this, it was a private static method on knight, but as I pointed out, I think it's going to be useful to more than just the knight. So I did a refactor operation and I moved it to a class called BoardUtils. And let's do a couple things. Let's make the BoardUtils constructor private. And let's have it throw a runtime exception in case anyone does try to instantiate it. So now it's just a utility class where we're going to put some useful constants and methods that are static. Now that we've done that, I want to come back to the night class and let's re-examine this rule that we've created for the night. Let's bring up the Wikipedia entry. And so we said that we've come up with these offsets that we can apply to a given night by looking at its current sort of tile location and applying the offset to see if that tile is not out of bounds and it's not occupied by a friendly piece, then it's a candidate location for us to move to, whether it's an attack move or an attacking move or a non-attacking move. But there are some exceptions to this case, and so I want to go over them right now. So let's take, for example, what if our knight were on A4? If our knight were on A4 and we tried to apply the -10 offset, so notice that -10 is one of our offsets here. From A4, -10 would be -1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oops, that doesn't seem to work, right? So this rule that we've created does break down under certain circumstances. And I would encourage you to pause the video at this point to discover what those edge cases are for yourself. I've already done that. So I'm going to go ahead and capture those edge cases in a couple of methods that I create. So coming back here, let's create our first edge case. Private static boolean is first column exclusion. So all of the edge cases that we run into if our knight were sitting on the first column of our chessboard. Final int current position and final int candidate position. Let's say candidate offset. Right? So what I want to say about this is I need a way to capture all of the tile coordinates that correspond to a given column or to a given row. So I'm going to pretend that already exists. It doesn't yet, but I'm going to pretend that it already exists and is available to me from the BoardUtils class and that it's public. So I'm going to say BoardUtils.first column current position and the candidate offset is equal to -17 or the current position is equal to, or excuse me, if the candidate offset is equal to -17 or the candidate offset is equal to -10 or the candidate offset is equal to 6 or the candidate offset is equal to 15. Okay, so there's a lot going on there, but let me see if I can help explain. what we're going to say is return. So what we're saying is we're going to introduce an array of booleans in BoardUtils, and that array of booleans we're going to call first column. So let's see if we can create that constant. So now that constant exists, and it doesn't have any values yet, but let's imagine right now we're just going to say it's equal to let's not say it's equal to let's say it's equal to null, right? So imagine if I had an array of booleans and all of the values were and this was an array of booleans of size 64, right? And all of the values were false except for the values that corresponded to the first tile, or excuse me, for the first column in our chessboard. So first column of 0 would be true, first column of 8 would be true, first column of 16, 24, 32, etc. Those values would be set to true. All of the other corresponding values of that Boolean array would be set to false. If I had that, then, and we'll flesh this out in a subsequent video, but if I had that, then it would be really convenient for me here, because I could say if my current position, right, I'd use that as sort of the offset into this array. If my current position falls within the first column of a chessboard, and the candidate offset is -17, -10, 6, and 15, I claim these are all the offsets where the rule breaks down if my current position is in the first column. Then I now know that I don't want to really, I don't want to do the rest of this work. So we can come back here and we can say here, we can say if is first column exclusion, this dot piece position, and current candidate, right? Continue. And why don't I rename current candidate to be rename current candidate offset, right? So that's where the rule broke down, and now I have that exclusion set up. This isn't the only exclusion. There's also a second column exclusion, a seventh column exclusion, and an eighth column exclusion. So let me go ahead and flesh those out for us. Private static boolean is second column exclusion, final int current position, final int candidate offset, and I'm going to say return BoardUtils second column current position, and let's say candidate position, let's say current position is equal, candidate offset is equal to -10, or candidate offset is equal to 6. Oops. I missed my braces there somewhere. create that constant. Let's see, let's let the IDE do the work. Create the constant field. Let's set this equal to null for now. Right? Right, and I encourage you to sort of verify each of these sort of exceptions to the rule, if you will. I've explained one of them, and I think that should help with understanding the rest. Private static boolean is 7th column exclusion, final int current position, final int candidate offset, and return board utils dot 7th column current position, and let's say that the candidate offset is equal to -6, or candidate offset is equal to 10. Let's go ahead and create that constant. Right, and we got one more. Bear with me. Private static boolean is 8th column exclusion, final int current position, final int candidate offset. Let's fix that little compiler error there. Keep misspelling static, okay. And return BoardUtils dot 8th column, right? Our knight's on the 8th column. And the candidate offset is equal to -15, or the candidate offset is equal to -6, or the candidate offset is equal to 10, or the candidate offset is equal to 17. Right? So the first and the 8th column exclusions are the most exclusionary. So let's go ahead and create that constant using the IDE light bulb. And you know, we haven't fleshed these out yet again, but we will. There they are, the first, the second, the 7th, and the 8th column exclusions. I encourage you to look these exceptions over. I'm going to double check these after the video and make sure that I got them right. But let's go ahead and include them in. So, or if we're the first column exclusion, or oops, where the is second column exclusion, or oops, I got is 7th column exclusion, or is 8th column exclusion, then we want to just sort of skip or continue through the loop. Right? And let's usually like to, what is this complaining about? Why can't I format this code? Oops. Okay, so we're almost there. Let's do some cleanup. First thing is first. Let's find out why is this complaining. I got an extra open parentheses there. The other thing I wanted to do is I declared candidate destination coordinate outside of this for loop, but it doesn't need to be. It's only really used within the context of this for loop, so I'm going to move it inside. And folks might argue that, oh, you're allocating more memory now by doing that, but I think I would at this point tend to side with the argument for better readability and more local scope. So I'm going to move that in there. Now this code looks a little bit cleaner. Let's go back to, let's see, did we have anything here? Here, I think we've got some extra parentheses here we don't need, right? So really it's just first column, current position is in the first column, and any one of these conditions is true, so we can get rid of that. Let's see, candidate offset is equal to 17 or 10 or 6 or 15. That's right. Same thing I think is going to be true here. The IDE tends to automatically snap in the closing parentheses, so I know that sometimes I'll get this, I'll sort of overdo it. I mean, I don't think there's anything wrong with what I had before, but just sort of gratuitous parentheses. This is really one condition. So let's get rid of each of those. Right, almost there. That's cleaner, and that's pretty good. One last thing I want to do is that in this interface, I said that I was just going to use, in the last video I said I was just going to use list of move for simplicity's sake. And really at this interface level, I don't need a list. You know, there's differences between a list or a set in Java, and I encourage you to look those up. At this point, I'd say it can be unspecified. So let's refactor and change signature. Oh, oops. Refactor, change signature, and let's have this be a collection. So I would encourage you, if you don't already know what the inheritance hierarchy for these things are, you know, the difference between a set and a list in Java. You know, in summary, a set cannot have any duplicate entries in it, and it's unordered, whereas a list is ordered and you can sort of get values at a particular index. But what I want to say here is it's unspecified. Whoever calls this method, it's unspecified. It's just a collection. It so happens that in our implementation we're going to use a list, but the caller of this method will not be able to rely on that behavior. Okay, so that's a lot that we've covered here. Looks like we have pretty much wrapped up the night class. There's going to be more that we come back to this for, but I think I want to stop here for now, and then in the next session we will fill in the move class more and the board class.